Today we are going to look at first order linear differential equations. The standard form of a first order linear differential equation is dy by dx plus py is equal to q, where p and q are functions of x. It's called first order because it involves only dy by dx, first order derivative. The solving of this differential equation involves 3 or 4 different steps. It may not make so much sense to you when I just tell you the steps one by one, but as we are looking at different examples, it will make a lot of sense. Step 1 is you find integral p dx. The p is picked up from your question, integral p dx. The second step is calculating something called integrating factor. We often write it as IF, the integrating factor, which is e to the power of integral p dx. Third step is you multiply the differential equation which is in this standard form throughout by the integrating factor. So every single term of this will be multiplied throughout by the IF. That's like integrating factor into dy by dx plus integrating factor into py is equal to integrating factor into q. But when you do this step, what's interesting is that the left hand side, you would notice it as we are doing examples, that this would always reduce to the derivative of d by dx of y times if. So this entire left hand side is going to just become d by dx of y times if. But the right hand side, it continues to be the same, which you need to simplify. And finally, we say integrating both sides, because now the left hand side is derivative of y into if. It's directly integrable. So derivative and the integral would cancel, and it will give me just y into if. And of course, you will have to integrate the right hand side. We're going to look at an example now. This particular question here, cos cubed x into dy by dx plus y cos x is equal to sin x. I would always check if the given equation is variable separable first. This is not variable separable because if I try to separate the variables, you will see that the x terms and y terms would get added up. Like for example, I shift this y cos x to the other side, so then I get sin x minus y cos x. So I won't be able to separate the variables. X and y terms are together in one bracket, okay? So the next thing is you could check if it is homogeneous, and it's not, because you have a sin x and it doesn't appear as sin of y by x. Homogeneous means dy by dx should appear as f of y by x, which is not going to happen in this. And this, finally, we decide that it is homogeneous. We decide this as linear differential equation of the first order because there is a single y here. And the standard form of it is dy by dx plus py is equal to q. So to get it into that form, I say divide throughout by cos cubed x. So when I divide each term by cos cubed x, here I get dy by dx, here I get y times cos x by cos cubed x, that's sin x by cos cubed x. A little bit of simplification we do on those two terms. So I get dy by dx plus y into, this would change to cos x by cos cubed x would make it 1 by cos square x. This we split it up as sin x by cos x into 1 by cos square x. So we know that 1 by cos x is sec x. So this 1 by cos square x is going to be sec square x, and this is going to be sec square x, and sin x by cos x is tan x. So my equation now becomes dy by dx plus sec square x into y is equal to sin x by cos x tan x into sec square x, which is equation number 1. Now this is in the standard form. Dy by dx plus py is equal to q. So where my p is sec square x and q is the entire right hand side. Now since it is come down to the standard form of a linear differential equation, I follow the different steps which we discussed. The first step is to identify p, which is sec square x, and find integral p dx. And integral of p dx is integral sec square x, which is tan x. course, I don't keep plus c, which can be justified as we do this question. So integral p dx is integral of sec square x dx, which is tan x, and remember we don't keep this plus c. Second step is to find the integrating factor, which is e to the power of integral p dx. That's e raised to integral p dx is tan x, and e raised to tan x cannot be further simplified, so e raised to tan x. And the third step is to multiply equation number 1 throughout by the integrating factor. So I multiply each term in this equation number 1 by the integrating factor, which is e raised to tan x. So e raised to tan x into dy by dx plus e raised to tan x into sec square x into y is equal to e raised to tan x into sec square x. And as we discussed before, if you look at the left hand side of this equation, which is this, you would notice that this is actually the derivative of y into e raised to x, y into if, y into the integrating factor. How do I check it? Okay, this is product rule if I have to differentiate it. So it's the first function which I have here, y into derivative of e raised to tan x, which would be e raised to tan x itself into the inner derivative sec squared x. So that's my u into v dash plus v into e raised to tan x into, which is here, into u dash, which is dy by dx. So that's perfect. So this, when I differentiate, I am able to get this. So I should realize that this is actually the derivative of y into my if all the time. So the left hand side, even if I hadn't shown this multiplication, I could have directly written d by dx of y times the if, whatever it is. But the right hand side, of course, it continues to be the same. At this stage, I'm able to integrate because this is already the derivative and I am undoing it. I am integrating it. So the integral and the derivative would get cancelled. So I say integrating both sides with respect to x. On the left hand side, the derivative and the integral gets cancelled. But on the right hand side, I put the integral sign and I think about what's happening here. Immediately notice that this tan x has its derivative present there, which is sec square x. So why not call this tan x as u? So I'm going to make a substitution, tan x is equal to u. So differentiating with respect to x, I get sec square x dx as du. So my question would now become, this is going to be u, this is going to be e raised to u, and sec square x dx together will become just du. So integral